Well, I've got something very special for you today. Joining me, the man, the myth, the legend, Caveman Jim, Mr. James Pryor, is here with me to talk about all things RISC-V and SiFive. Well, all things SiFive, and then RISC-V would be under that umbrella, I suppose. So, if you've been living under a rock, RISC-V is taking the semiconductor industry by storm. But I think Mr. James Pryor could probably tell you, a better blurb than I can. So, what's SiFive and RISC-V for the uninitiated?
Yeah, sure. So thanks, Wendell. Really appreciate you making the time. Happy to talk to you guys, get some questions. So RISC-V, SiFive, what's happening here is about 10 years ago, a group of students at a Berkeley computer science lab needed to prototype some different designs, and they needed an instruction set architecture that was flexible and open, didn't require large amounts of licensing fees, et cetera, yada, yada. And there wasn't one. So being those innovative kind of guys that they are, they just up and built one. And 5 years later, they found themselves in the position of like, hey, there's something really to do this. So they founded a company, called it SiFive. And now you have the RISC-V International Organization, which is an open standards organization comprised of technology company members as well as individual contributors that guide the development and extensions of RISC-V as an ISA, and SiFive, who are out there building cool microarchitectures and platforms and solutions for our partners and customers.
Now, I'm only a lowly internet bozo, like not even a computer janitor, and I will be the first one to tell you that I don't have a super deep understanding of any of the stuff that's in play. But one of the reasons for me that's exciting with RISC-V is that it feels like modern tooling on what is a very, like, computers are new, but they're also ancient. And so, like, how we were doing computers in the 70s feels like how we're doing computers in, like, watches and embedded systems and stuff like that. And the thing that is really awesome about the RISC-V development kit that I got, I think, last year, is that it feels like it's a lot of the learnings of modern computer science are in that, versus when you work on some other stuff, it's like, wow, they've really bolted on some sanity into what is fundamentally, it's like we just didn't know any better. It's like we didn't know we needed indoor plumbing. We didn't know we shouldn't, poop in the streets. But now we know. Let's let's design something that's a little bit less arcane than that, and that's what RISC-V is. So it's got to be really exciting.
Yeah, a very exciting time. I love your analogy of proprietary ISIS as pooping in the streets and RISC-V being the scalable model of clean hygiene for everyone. But RISC-V is based around the premise that the most important interface in the machine is the interface between the software and the hardware. So how do the two talk to each other is an incredibly important part of any computer machine design. And what RISC-V does is kind of add lightness. So you start with this very lightweight 60 or so instructions of the core fundamentals that you need to build some kind of device that can be called a computer, and then add on the bits and pieces that you need for your specific application. So if you look at how the industry is progressing right now, it's very much focused on there's a Cambrian explosion, as Dave Patterson puts it, of AI and other kinds of chips, right? So what's happening there is that general purpose processing has proven to be very, very useful and got us to this point. But now if we're going to significantly advance in terms of performance, energy efficiency, workload efficiency, capabilities, we need to get really workload focused. And for SiFive, that's the opportunity, right? Is building the workload focused platforms using RISC-V at its heart, because it allows us to be very nimble. And we have got some other secret sauce things that we do for our architecture style of designs that let us be very scalable and configurable. So in RISC-V as a base ISA, you've got the extensibility of different extensions. So you can add on if you want to have different things like vector processing or deep math functions, or even just picking out some of the base things that you need for an application processing core versus an embedded core. So all of those things are optional, which gives you a very lean base, which means everybody can pick out what you need. So a lot of advantages there. The open nature means that it's auditable, it's extensible. You don't have to, guess what's inside of it and extra. It makes security easier to achieve because you don't have a whole bunch of extra instructions, microcode, etc., that are, for other people's systems, but you have to have because you're using the same thing. So from a technical perspective, a lot of advantages, and you can imagine from using fewer instructions and simplifying your design, you can use less area, make sure chips easier to manufacture, and that obviously helps with the cost of improving performance and everything else. So that does, at a basic level, really rounds out why RISC-V is seeing its moment right now.
So in the past, I would be going reaching back all the way into the '80s. Some of the imagery that was bouncing around my head as you were talking was things like, okay, we're gonna have this standard microprocessor in this thing from the '80s, but we're gonna wire it into this bus or this particular device or this other device. But the drive, it sounds like the drive on the costs of manufacturing, the lower the cost of manufacturing and this kind of thing, is really driving the same kind of packaging that was happening in the '80s is now just all happening on chip, and it's like you get one piece of silicon, so you can go. I think you guys have a thing on the online where you go on the store and it's like, okay, I'm starting with the RISC-V, base starter, and then you got this sort of wonderful marketplace of awesome stuff that you can just sort of, it's like, okay, this vendor has this that I can bolt on, and this that I can bolt on, and this that I can bolt on, and you literally have a fully assembled piece of silicon that has a lot of intellectual property in it, but you've put it together all in one package instead of having to assemble, the whole microelectronics thing.
Yeah, that's a very good visualization because gone are the days where you have big fat CPU core and some cache, and then you've got a memory controller and a bus interface, and that's your chip, and everything else plugs in outside of it, right? We've now got multi-core, we've got custom function acceleration, whether it's audio encode or video decode or some kind of AI acceleration, or if it's something completely different, an image processing unit. There's all kinds of funky new cores getting put together, as well as controllers, as well as interfaces and buses and fabrics. And all these things can be built, with proprietary, even self-made architectures. But using a single common architecture gives you a lot more scalability. You can find more engineers that can work on your stuff. And then you can also use existing technology. And every software developer knows that proven code, copy and pasted, works way better than brand new every single time. So there's a lot of ways to improve the quality, especially as you're getting into billions of transistors. You've got to worry about these kinds of hand placed, fine tuned designs. It's just not scalable. So yeah, there's we have a concept at SiFive of Core Designer, which is kind of a front end based in the cloud on how we can show you the configurability of our cores. So we currently have four microarchitectures that range from a two-stage simple embedded pipeline design all the way up to a 12 plus triple issue out of order superscalar design, and you can really adjust the parameters of the cores in a very very unique way. So like if you wanted a core that had no floating point capabilities, we can do that for you. You can do that yourself using the Core Designer program. So you can really try it out. You can get the subscription to Core Designer, configure a core, download it, try it on an FPGA, and try to model your workload and see what are the things that you need in the core before you've even committed to a project. So it really helps accelerate the front end development time. It reduces front end development costs, great for startups and mature companies. And it really lets you understand how to fine tune for your workload. So a lot of configurability is SiFive's weapon in, how do you stand out when you're using an open ISO that anybody could use? Well, this is how, right? With standard core offerings that are immensely configurable, and then we can go to the next level of a custom engagement to really define a platform together with a partner.
Yeah, in thinking through like use cases and scenarios and just how everything moves. I mean, a lot of the people in the audience may not realize how long historically custom silicon development takes. I mean, from the time that you're designing things, doing like the circuit architecture with very expensive, very proprietary software, and then running simulations that are running at a tenth or a 20th or a hundredth of real time speed just to do the validation, and then even like doing all of that even before you design masks for a wafer. That could be a couple of years of work. But with what you guys offer, it's all of the tooling and everything necessary to just, like you say, copy and paste. And that means that innovation can move a lot quicker, I think.
For sure. We actually did a great partnership with TSMC and a couple of other of the design companies, Microsoft. So it was a fully cloud-based design instance using TSMC's OIP framework. And we were able to go from a concept of a chip to booting Linux on hardware in 183 days. Because
That's the blink of an eye.
right, 6 months, right, to get to hey, it works and it booted Linux, so now you can work into refinement. So thinking of time to market, thinking of being able to, you know, do those kind of things, why would you want to do that? If you look at the growing markets and how fast they appear today, new markets emerge in 6 to 12 to 18 months and get an established player. So if you want to be that fast mover, that prime mover, and really take advantage of that, you've got to have that agility. And that's one of the advantages that SiFive offers, and it's powered by the extensibility of RISC-V.
One of the advantages, one of the questions that I had, and one of the advantages that I suspect RISC-V has, but you could probably elaborate on a lot more, is that when we talk about the tooling and it's a lot of these concepts are just very, very abstract concepts. And one of the instances that I thought of as very concrete, something that I sort of experienced recently with an embedded system that has an older MIPS-based design, is security. And because you have the same code, the same sort of base, your security, your tooling around your compiler and the tools that you give developers for actually developing on software long after the device has been built is going to have a lot more longevity. Because what I ran into on the MIPS-based project was address space layout randomization had been broken for years, apparently. It took forever to be implemented, and then it was actually broken in the compiler and no one noticed. And so, in an era of, Spectre and Meltdown and all this other stuff, the tools for working on those things aren't really there. It's like having a truck that's neither, standard or metric, or, imperial or metric. It's like and it's like, okay, you're going to need a socket wrench from Venus. And it's like, well, it's going to make it really hard to work on this. It's going to make it really hard to get parts. And with RISC-V basically being everywhere, or at least the vision for RISC-V basically being everywhere and standardized, it seems like a very concrete, crystallized piece of awesomeness is that all of the work that everybody is doing in terms of security research, the entire community will benefit from all of that work.
Yeah, for sure. We're a very strong contributor to open source. We can, make tools available. We introduce new patches for the Linux kernel and for popular compilers. Recently, SiFive worked with the Barcelona Supercomputing Center group to build a new API for LLVM and GCC so that you can use the upcoming RISC-V vector extension with those compilers. So, that's work we could have done in isolation, kept to ourselves, but it's better for everyone if that's available for everyone to use. So we can help advance huge projects like the European Processor Initiative, where they're using RISC-V vector-based technology for acceleration of AI, and it helps for all of our customers too, and all points in between. So that's the benefit of working with an independent, neutral standards body like the RISC-V International Organization. Calista, the CEO, has done a great job of expanding the membership. I think we've seen like 100 new companies and partners come on in the last 12 months or so. Just, now it's over 400 industry companies and partners from, research universities through it's like a who's who of technology. So,
Yeah.
Tons of interest, tons of development, and this is the way that you get your voice heard into the technology of tomorrow, right? It really levels the playing field from, the guys that have super deep pockets and can go off and do their own proprietary things, influencing what everybody does. Because now there's an organization where every specification is ratified. And that's true for security as well. SiFive Shield, which is an open specification for platform security, is going to be part of the RISC-V international standards as well. We're going to contribute that. We've already published some initial papers, and that'll help everybody build truly secure chips using RISC-V that have scalable and really good multi-domain security. So you can have a really nice secure chip and understand where your vulnerabilities are, because you're able to audit everything because it's all open.
Yeah, I mean, there are so many, for people in the audience that don't know, in the hardware that's out there today, right now, that's still in use, it's not even obsolete hardware. And we're not even talking about like the wildly insecure, like Internet of Things, toasters and light bulbs and stuff, just like actual, real sort of non-computer computers, stuff that's plugged into the network. There are a lot of dangerous insecurities that have crept in because those ecosystems, there hasn't really been a commercial impetus on the companies to maintain security level. I mean, I talked a little bit about MIPS, but it's one of those situations where you can license it, and the company theoretically that has the product could improve the ecosystem, but there's no commercial incentive for them to do so. The Intel 8051 microcontroller is another one that I have a lot of experience with in terms of like it being kind of a dumpster fire in terms of security. There was a huge kerfuffle just a couple of years ago because there was a company that makes USB controllers that are based on the Intel 8051, and it turns out they're reprogrammable. So you can have a virus in USB at the hardware level that is infectious from device to device because you're able to reprogram the 8051 microcontroller that exists inside of USB devices. And that was sort of like a oops, we didn't even think about that. And again, it's all because it's turtles all the way down, but it's because the 8051, which is an industrial controller, it's like the 80s. They keep calling, and we're not even thinking about this stuff in the 80s, and so hearing that a lot of this stuff has been anticipated and there are academic papers and it's all in the open, this is absolutely where we have to be for ubiquitous computing, because those devices just weren't even designed with that in mind, and it's coming back to bite us now. I mean, they're devices that have to be retired before they're really obsolete because they weren't designed with security in mind, or they weren't designed with really forward compatibility in mind. Because even if you wanted to go back to the 8051 and harden it in terms of security, there's not software tools that a developer can use to really do that.
Yeah, that's a very good point. Building an open ecosystem, building open partnerships is really going to help us get to, as you say, ubiquitous computing. That is the key to security, is just being able to audit and understand and refine it and improve it over time. It's never going to be done. There's always going to be something new to do. So it just you got to start somewhere, then start from a place of openness and collaboration. That's a great way to go forward, I think.
Yeah, I think just being able to capture all of the work that somebody is going to do some work on that, and if the community or SiFive itself can benefit from some of the work that its customers need to do for this, that, and the other, then that's going to carry things forward a lot better, a lot more quickly than what the alternative has been for the last few years, which is like, well, one major integrator might do a lot of work, but then that integrator's not really going to share anything because there's no commercial reason to. So it is really exciting to see all the possibilities for where where RISC-V can show up. I mean, I think the last time we talked about it, it was we were talking about, was it Western Digital, like embedded external hard drives, like it shows up there, but it's it's a great solution to that problem.
Yeah, there's a lot of spots for it. So to date, SiFive has really had a lot of success in the embedded space because we offer area and power advantages as well as great performance. Plus, we've got the tools to help make the migration easy. So we're seeing a lot of companies adopting that for really, even just traditional uses, but also more advanced where an embedded core is now being almost an application core, but you need real-time determinism, you need security hardening, you need fixed function, you need to reduce surface area. All of that stuff is great for a RISC-V use. Western Digital have done a great job with their own RISC-V development. We've partnered with a lot of different companies. We have a number of design wins, over 175 now, with 80 different companies, including 6 of the top 10 semiconductor companies, and they're all working on new designs based on RISC-V with SiFive inside. So we've got a ton of momentum, and all of the recent events have really just put a focus and a spotlight on SiFive as, hey, what else can we do? Where's our inflection point right here to maybe re-enter a market that we missed or didn't succeed in, into a new growth market? How do we differentiate, right? Because if everyone's using the same core technology and the same software, what does the end product look like? Is it just a race to the bottom in price? Or is there some other way that we can differentiate on experience and build a better product? So that's really the opportunity for us right now.
Yeah, I definitely see that there's a lot of opportunity pretty much everywhere in the embedded space, from toasters to security cameras to the global stage and the trade wars, and we won't get into that. But there's just so much opportunity for people to be able to control their intellectual property and have really good tools for, like you say, the auditing and everything else. Um, but that also brings me to like one of the first questions, which is when can I get a RISC-V developer workstation?
This year. So we'll have, yeah, nice, easy one to start off with. We're gonna, SiFive is announcing our new hardware that's going to be part of the Linley conference at the end of October. I think it's the 29th. We'll have our CTO, who's also one of the co-founders, one of the co-inventors of RISC-V, Yunsuk Lee, give a talk on our new FU740 chip, which is a multi-core application capable RISC-V processor. It's got some great features. It's coming in a PC form factor, so it'll make it really easy for professional developers to get their hands on it and put it into a system and understand, like, here's what we can do. So the intent here is not to go after PC market share. We're not trying to build a laptop or a PC for watching videos or doing email. What we're trying to do is enable Linux developers to build new kernels, new drivers, new everything that they want to build, or a real-time OS that they can use in their company's strategic use of RISC-V. So this is how we do the broad enablement of the world of adopting the RISC-V ISA with an application core. It's going to ship with a Linux distro and a real-time OS. So out of the box, you'll be able to just plug it in into your PC build, go ahead and start it up, and go straight to a familiar environment. And from there, the world is yours to command, right? You can build whatever you need for your company or your personal use. We're really focusing on the professional developer for our partners, and that's the main focus here is just to really kickstart the ecosystem, kind of like how Microchip have done with their PolarFire SoC Icicle kit. That's a great board for building prototype applications because you've got RISC-V cores inside of their SoC along with a nice healthy sized FPGA, and that's got SiFive cores inside there too. And you can get started on prototyping your application and getting ready with your product development. So a great partner for that.
So is one of the possible workflows that you could you've got the developer workstation and you go online and you put together the IP and then you program the FPGA on the developer workstation, and then you're actually trying basically a prototype of what the production hardware would be in 180 to 360 days later.
Yeah, that's certainly very possible. You could develop your own IP that fits on that FPGA, and you can program it on the RISC-V bare metal environment and run it natively, accelerate it using the FPGA, and then kind of how everything's going to work before you even got to trying to tape out a chip. So it's really going to help you understand where do you need workload acceleration. So if you're thinking about how do I uh, analyze my workload, a lot of the time it's really down to watching performance counters and understanding where how the code changes over time. That's really not possible until you're getting some really good hardware um, processing going on, like on an FPGA. So that's the benefit of having this kind of environment put together is you're going to get to that very, very quickly.
Yeah, I was just thinking about real-time operating system applications, even things like vision processing or AI applications or anything like that. I mean, it's just insane to think about that. An entrepreneur could prototype something and have it basically ready to go in a year or less than a year, and have access to all of it, all of this IP in a marketplace that they could build their product on, but also their own special sauce. I mean, that is, you know, 10 years ago, that kind of development would take 10 years, unless you had tens of millions of dollars or hundreds of millions of dollars.
Yeah, for sure. And that's one of the benefits of SiFive's IP partnership model. We have this thing called Design Share, where we have some IP already integrated and ready to go, so that you can understand upfront the licensing costs, how to use it, how to interfaces with our technology. So there's some great IP in there, from SIVA for DSP, ISP, other audio processing, digital vision processing, etc., as well as Imagination for some of their GPU and NPU technology. But it doesn't stop there. There's a ton of other different partners that we have. So you can really explore building your own chip in a single environment so that it's really smooth, right? It takes out a lot of the, oh, hey, now today I need to be an IP licensing legal expert to progress my project, right? We can help move all that out. So that's a big advantage for startups.
Is there a commercial opportunity for, let's say that you were a small developer, a 1 or 2 or 3 person shop, and you had the developer workstation with the FPGA, and you were developing new intellectual property that could run on the FPGA, and you come up with, a new kind of noise suppression or a new kind of whatever. Is there an opportunity for those small developers to be able to offer up that intellectual property in the marketplace?
I'm sure we could figure something out depending on the applicability and if the market focus. I'm sure that would work. It's just a matter of proving it out. And everybody loves to buy silicon proven IP, which is what we offer. So once you get to that stage, you find a partner to do a test chip, then that really is the accelerator. But yeah, there's no reason why that couldn't be a conversation to have.
It's like the App Store, but empowering the App Store for smaller development outfits that are able to license their IP to larger companies. I mean, it's always nice. I mean, you've got the larger companies that have a lot of intellectual property, and they'll happily license that out. But it's always nice when there's the market can go the other way. Some small, agile, smart developers are able to come up with some really killer IP, and then have larger companies license that from them.
Yeah, that's definitely on the horizon. Is something that's going to happen.
What's a project that's in development that you can talk about that you're really excited for?
Let's see.
That you can talk about.
Yeah, that's the sticking point there that I can talk about. So, I mean, broad strokes, we've got some great partners. I think there's a ton of opportunity now. We talked about embedded and how we're seeing great adoption there, and I think that's going to evolve into things like computational storage, smart NICs, other data processing units, because there's going to be more of a need for offload and intelligence in those devices. And that's the part of the conversation about AI moving from the data center and an accelerator into the edge and the endpoint. So those are the kind of opportunities that I get kind of psyched about, because there's the things that are going to reduce latency and improve experience for people everywhere, because it could be something that's consumer based, it could be something that's never seen by a human, but it just makes stuff work better around you, like a smart factory or better traffic light management. I don't know. There's a ton of opportunities. So there's a lot of things in the AI inference processing space and smart infrastructure space that are very exciting, that we're exploring right now, for sure.
I said, I think in one of my recent videos, I said that because our next questions are about the NVIDIA acquisition of ARM. And I think we got a couple of questions about that. And I think one of the things that prompted some of those questions in one of my videos, I said that the way I saw it, it seemed like RISC-V was coming for ARM, at least at the low end. They were coming for ARM's lunch. And I definitely believe that. But again, based on a computer janitor's limited understanding of the larger thing, but as a developer working on stuff, the tools for some things are terrible. And so it's like you're asking me to use rocks and sticks over here, but over here it's pretty good. Generally, the ARM systems that I've worked on are pretty good, but they're really expensive. And the RISC-V system that I worked on has actually been pretty good. We got the question about the workstation. I'm running Debian on the embedded system over here, and it's a passable experience. I've got an older AMD GPU in it, and it's basically okay. It basically works. And that's the one with the FPGA and the single PCIe slot. and it's not a terrible experience. It's actually pretty good, and that's like, early generation hardware, I guess. And so because that developer experience was so good, it's like, why would I ever use anything else? Especially when we're buying this in silicon, it's going to be so inexpensive. I mean, this, like, we can buy somebody else's, mass market, mass produced RISC-V thing, and then my software is just going to drop right in because Linux and everything else runs well. Whereas Linux for MIPS is just not in a good spot at this point, and at least in my opinion. And so, ARM, it's like, if they're not going to make a bunch of money from the low end, but they're in phones and everything else, it's like, that's an opportunity for RISC-V, because you're going to have the marketplace, you're going to have the short development cycle, you're going to have all the stuff those embedded systems really want, but also forward compatibility with software. As those companies go forward, they're going to be able to support their 5 and 10-year-old products without having to employ an army of 50 developers that are figuring out ever increasingly clever hacks to try to keep that obsolete hardware going.
Yeah, that's an interesting discussion. So, for us, it comes down to, we don't see it as either or. We see it as and. So, number one, we think that all the technology companies, semiconductor companies, want a competitive market. They want choice. They want options. They want differentiation. I think that's pretty easy to say, yeah, that's true. So number two is, do you take the view that the markets today are the only markets that exist? And that's where we can say, no, there's new markets coming, right? Automotive and assisted driving and internal entertainment systems are a massive growth thing. There's a massive growth opportunity in AI at the edge and in the data center, in infrastructure, like 5G, the way that it's causing an entire rip and replace of every bit of existing infrastructure, because you need new baseband, new stations, new handsets, new everything, right? And they're all pushing towards Open RAN as well,
Yeah.
right? Then there's a whole ton of opportunity of growing markets that are out there, and it comes down to, do you believe that a win for SiFive is stealing a socket, or should every socket be won on the merits of the technology? And we take the position that it's open, right? Every socket is yet to be won, every socket is yet to be awarded, and we should have a fair shot at it on the basis of the merits of our technology. Now that's coming, that conversation has come to the front because of the recent industry acquisition, the planned acquisition of NVIDIA for ARM. I think they're going to continue to be successful, but I think that the growth of the opportunities, the markets that's out there, is going to mean that there is room for everybody to be successful in different ways, and our success, that's fantastic, won't be at the expense of anybody else. So we can succeed without having to steal someone's lunch, right? There's going to be a buffet, and we can get as much shrimp as we want because there's plenty for everyone. So,
while you guys might not be stealing anybody's lunch, I don't think MIPS is going to get any more market share on those new sockets.
and that's not really because everyone's holding them away from the table. It's because they don't have any merits to come to the table with, right? They're out. So
Yeah,
that's the conversation, right?
yeah. I think that's for me personally. That's what it comes back to, is like the tools, because I just want to solve a problem. As somebody that wants to build something, I just want to solve the problem. And I care a little bit about the minutia of how the problem is solved. It's like, oh, I've used an 8051 in my design. This is amazing. It's like, oh, by the way, we can mine Bitcoin with that. What? Yeah, we're mining Bitcoin at a really slow rate for some guy in Russia. What? And so I don't want to have to think about those things as a developer. And so it's like, it translates to the quality of the tools. I want to have the best tools that I possibly can to solve the problem. And some of that's going to be down to reputation. It's like, nobody ever got fired for buying IBM. But in the semiconductor industry, I sort of see this sort of shrinking thing. And so it's like, well, I could definitely see what you're saying about the buffet. I also see that there's going to be perhaps more diversification than there has been, historically, in that space. Because like Intel, for example, I think Intel's been trying really hard in the mobile space. I've got this mobile phone which has got mobile x86, but it's like, x86 in a phone can make sense because of the homogeny and all the reasons that you described for like, everything is there and it's all the same. You write it here and it works over there. But at the same time, it's like I don't need to run Excel for DOS on my phone necessarily. So there's some cruft here that I've brought along just for the ride, and it makes it hard to abandon those things. So that's one of the reasons why I think ARM in general has took over the mobile space, and it's not going anywhere anytime soon in the mobile space. But you're right about edge compute and computing getting even more ubiquitous. And I think it's probably true that if the friction from deploying that everywhere is a lot easier, then yes, you will absolutely get more computers everywhere, because it was super frictionless to deploy more computers and have more computers work with the pre-existing computers in order to solve whatever problem it is or make whatever it is go away. And I, as a developer, it's like, okay, we're going to wrap your old 8051 system with this RISC-V system. We're not going to try to re-engineer or replace the 8051 system. That's just a sunk cost. We don't care about it. But we're going to surround it with this nice RISC-V based firewall, and you can just write us a check and we'll make the problem go away. It's like, here's your check. Sounds good. Let's do it.
Yeah, there's a lot of that kind of thinking of the fastest, easiest path to protection. And like you said, it's based on developer enablement. And that's why, we take that seriously at SiFive. You probably saw earlier this year, Chris Latner joined SiFive. He's the president of product and platform engineering. Did some great work at Apple on Swift, at Google on TPU, at Tesla. Also, LLVM is his creation. So very nice set of experience on building scalable, high quality, enterprise grade software and tool chains and tool sets that people can really use. And that's really going to start to show up in our offerings as we continue to grow and evolve. So that's a lot of the reason why we had that great recent fundraising round, $60 million led by SK Hynix, but also Sutter Hill, Qualcomm Ventures, Intel Capital, etc. Because we've got the right people in place and we've got a great idea, and we don't need someone to fail for us to win, right? It's a much stronger proposition. I don't need to go around saying something's dead or old or whatever else. I can say, here is the green pasture, here's the path, come on over, the water's fine. So that's a much nicer way, right? It stands by itself.
I could be the bad guy. It's fine. No. You're exactly right. You're exactly right. That is a much more diplomatic approach, because even companies that have an interest, I'm sort of beating up on the Intel 8051, but at the same time, it doesn't make financial sense for Intel to continue supporting the 8051, because it's kind of a black hole of insanity at this point. It's like it's more baggage than new product that's going to consume, those sockets that you're talking about. There was a need to solve a problem, and while it's not quite a square peg in a round hole, it's not as good of a fit as potentially SiFive is. And so I can definitely appreciate your diplomatic approach to saying it that way. I definitely agree. I mean, it's a better fit, and everything here looks pretty good for that. So that's a pretty good answer.
Glad you liked it.
We had some other questions that were kind of along that same line, which is a couple of questions that are relating to like GPU acceleration or video acceleration, and RISC-V in things like Android-based devices, maybe a phone, maybe a tablet, Chromebook, something like that. Do you see, what sorts of things are going on with RISC-V in terms of video acceleration, or has that been a thing from customers, or anything that you can talk about?
Yeah, so that's not something SiFive has looked at. I know that Think Silicon, I believe, have worked on a GPU based on the 64-bit RISC-V instruction set, and I saw that at the RISC-V Summit last year in December, running real GPU workloads. I think John Petty did a nice write-up on that, so it'd be good to check that out. There's definitely the conversation about it. Wherever we come across a general purpose acceleration kind of discussion, like an application processor core, then it quickly turns into how do we differentiate, integrate, and really improve the experience for the user, right? Because they've got a great solution already. What they need now is a greater solution. So we're seeing some conversation there. I think that Patrick Little, our new CEO, coming on board, his heritage, he helped grow Qualcomm's mobile and automotive businesses. He's having those conversations right now on the back of the NVIDIA ARM acquisition and the speculation of the problems that's going to cause. So, we've already got an embedded core in a Snapdragon shipping in the 865 right now. So there's proof of concepts happening everywhere. What that turns into, as a handset or something else, that's the stuff that's TBD. And that's where you've got to have a long-term vision, a partnership, and a lot of investment. So that's really where we're hoping to grow. We want to move into the application processor core space even more deeply than we are now, but in a way that is not trying to just say, hey, we're going to replace your general purpose application processor, because that's not worked, right? They're done scaling. Now you need accelerators from image processors and video decode and other kinds of manipulation to something else. So that's why we've been talking a lot about the vector extension, having an application core that is vector math capable with very high flexibility, ability to scale from 4096 bit to 128 bit in software without having to know the hardware underneath is a much better approach than what you've seen elsewhere. And that's going to drive a ton of adoption in those use cases where you need a lot of parallel intensive workloads and stuff, right? It's all the advantages of being more flexible than SIMD and still being extensible and flexible and more efficient than a general purpose CPU. So
Yeah.
pulling that tightly integrated into the core ISA, so you've got that converged core, is a huge, strong in for it, right? Because it means some people looking at it like, oh, well, maybe we can do, something. Maybe we don't need so many special purpose things, and we can drop some of the licensing we're doing, or maybe it means that function that's doing actually gets really, really good, and we're class leading in that experience now. So that's the conversations that are going on. I wish I could give more details, but that's where we're at right now.
Well, listen, that's enough to whet developers' interest, I'm sure. I mean, they will really perk up at not having to think about it, and it's just sort of handled in software. Because I'm sure they're sitting there thinking, it's like, look, I already feel the call of the void enough. If you can make it to where I don't have to think about whether or not this is 128 bit or 4096 bit or whatever, that's going to make my life easier. And that, at the end of the day, making people's lives easier. Amazon AWS is built on making people's lives easier, and it's not the cheapest option, but it does make people's lives easier in terms of all of the stuff that's going on there and all of the stuff that they offer. We had a couple of questions about what about picking up an inexpensive developer kit? Like, I think you guys have a Raspberry Pi like thing. Like, where do you pick that up? What is that? Like, how does that work?
Yeah, so previously we've had two boards available for purchase. We've had the SiFive 1 Rev B, which you can get through, I believe, Mauser right now or Crowd Supply. You can grab those; they're in stock and shipping. 50 or $60, I think it is. It's an embedded processor. Got some nice basic input-output things. You can really do a lot of work with that one to understand what is a RISC-V processor and build some cool IoT devices, etc. We've had the SiFive Unleashed board, which I think you've been playing with. It's got the FPGA expansion, all that kind of stuff.
It's a lot of fun.
A lot of fun. And that one's going to be replaced by a new board that's coming out at the Lindy conference. So that's a transition we'll be making. New one's going to be faster, better, easier to play with, all that kind of good stuff. There you
Yes,
go.
it's a crazy amount of fun. I've got Thunderbolt in there.
Oh, did you get Thunderbird on RISC-V working?
Working in quotation marks.
Jesus
things
fuck,
like
huh?
things like DMA are a bit of a challenge,
Yeah.
but but there's an FPGA there, so I mean, there's a lot you can do on the FPGA to just kind of like ham fist it together.
Yes,
But yeah, I don't know. So it is a crazy amount of fun, and it's really, that's what makes it exciting, is like having the hardware to play with and seeing the performance and seeing how much is there, how quickly, and like what the vision is in the marketplace, and like what it's going to open up for entrepreneurs. I mean, it really will be game changing, because I'm personally of the opinion that sometimes larger companies, they sort of get bogged down, and they maybe don't innovate as quickly. And a lot of the time, it's easier to innovate through acquisition than it is to innovate through, your own internal people sort of lose sight of what kind of problem they're solving. But with this, it's it gives you full access to pretty much everything from top to bottom. So it is really genuinely very exciting.
Yeah, for sure. That's really the intent behind the boards, is to help people, get to know it, capture it. RISC-V is being taught at universities across the world. The Patterson Hennessy architecture book is based on RISC-V now, so we're expecting to see a lot more RISC-V based development coming out very, very soon.
Well, we're about 45 minutes in, so we should probably start to wrap it up. But is there anything that I haven't asked that you were hoping that I would ask, or anything that you want to share or say, or this is your time, because SiFive is. We need to do this about every year or every 6 months at the rate you guys are moving. What was it? Every 180 days? About every 180 days.
Yeah, no, it's a great time to be part of the technology industry. There's been, a lot of predictions that have gone uh, different ways than what people thought. So I remember people saying, PCs were dead, the market's shrinking, and boom, it's back because everybody needs a PC. And then there was all the, hey, no one can take over the data center, the software load migration is too hard. And hey, there it goes, it's starting to move to different architectures. So I think that fundamentally, if your answer to why isn't this going to be successful is because we've never done that before, that's the gut check you need to make, right? Give it a chance, because there's going to be a good way to do it with RISC-V. SiFive might be the right guys to work with on this. We're super focused on the workload specific acceleration, on finding customers who are going to be partners for building new platforms. We're not interested in the general purpose compute market today. It's we don't want to build SiFive branded laptops, chips, notebooks, PCs, whatever it is. That's not the game. The game is to make high performance architectures that are going to be part of some really cool experiences along down the line, and that's the focus. So I'd say that's my number one thing of what I want people to take away from today is it's just going to continue to grow from here. RISC-V is real. We're seeing more and more adoption. I could give you the list of all the places that we're shipping today, from the Synaptics USB Type C video controllers. We're inside of those, through to coherent logics for Mil Aero, and some really focused TLA customers that are doing wonderful things. Network processors with Innovium. There's just this groundswell of adoption, and SiFive's leading the way. So keep an eye on us. Give us your support. We're hiring. We're looking for talented programmers and engineers. Check out whether you want to be part of the RISC-V uprising and get in on the ground floor.
Yeah, I didn't think about networking and 5G until you mentioned it, but we are at a point where, like, inside of general purpose systems, if you want to do, use a desktop processor, let's say, to switch, a gigabit's worth of traffic, okay, that's not unreasonable. I mean, a gigabit, that's a billion bits, but that's not unreasonable for a modern microprocessor to handle. But okay, we're going to switch 10 gigabit ports, which is not unreasonable for what you might find in a cell tower with all those frequencies and antennas, and they're very, very, like a 5-degree band. That ain't happening with general purpose. That's going to take custom silicon. And the faster you guys can drive the price down, the faster we will see sort of state subsidized equipment for that go away. And also, everybody can be secure in that, hey, this is the open ISA, this is how it's built, there's nothing weird going on with the hardware, nobody's playing any shenanigans with the hardware. And you have that kind of a switching capacity in silicon managed by RISC-V cores. I've got an Arista switch, which is a Broadcom chipset with an x86 in front of it, and you can program the Broadcom to do certain kinds of packet filtering and stuff like that in silicon, but it's, big giant pieces of custom silicon that cost a crazy amount of money like 10 or 15 years ago, and it's basically just obsolete at this point because it can't, like, all of the fancy new stuff that you need to do, like RDMA, is a little buggy and it doesn't work and it's got problems. But having something like RISC-V at the heart of that with more modern IP and that shorter product development cycle means that products like that are only going to be way less expensive. And so just like the whole networking branch for the opportunities for RISC-V is really tremendous, I think.
Yeah, definitely a ton of advantage there, and shorter development cycles does reduce the cost for a company to build a new product and iterate on it and improve it. So you can see an advantage there. You can also see a better experience. So the value is higher, and I think that's where most companies are going to be focused on. Like, how can I not just? I don't want to race to the bottom anymore. I want to race to the best value. That's where people are seeing the biggest impact on not only the benefit for the world, but the experience in the hands of the user or end technician, whatever it is. But the people who pay for it all are appreciative of it, because better value results in a more sustainable long-term company that's around to continue to develop products and support them as well.
Well, those are all of that are very laudable goals for SiFive as a company, because we definitely need that. We definitely need these kinds of sort of public standards or public fittings, I guess. I don't know. It's like community plumbing is one way that I could go with the analogy, but also just standards for how everything fits together, because nobody wants, like, okay, you got to start from the beginning because of intellectual property laws. And it's like you get bogged down at the rocks and sticks level. So it's really exciting to not have to worry about that and just focus on innovating, but know that the foundation that you're building on is solid.
Absolutely. It just imbues a sense of trust and permissiveness, right? You feel like you can do what you need to do, so you're ready to get started. So it spurs innovation and just that. Let's give it a shot because I think it'll work. So that's a great place to be.
Awesome. Well, this has been an awesome chat. All things SiFive. I'm sure you'll be lurking in the comments, and so if you didn't get a question in, you still got a little bit of an opportunity. Or if you're looking for a job, definitely check that out. I'll try to have a link to that in the bottom of the description. So thank you, Mr. Caveman Jim, Mr. James Pryor, and I look forward to the next time we do this, which shouldn't be too awfully long.
That'll be great. Thank you so much, Wendell. It was great talking to you.